Section 1.3, Transformations of Functions. Part 1, Types of Transformations. We'll start with the function f, where f of x may represent one of the toolkit functions, such as, for example, y equals square root of x. Horizontal transformations, changes to the input of a function, cause horizontal transformations through changes to the x coordinates of the original function. One example would be f of 2x plus 3, or y equals square root of 2x plus 3, where y equals square root of x was the original function. A vertical transformation comes from changes to the output of a function, or the y coordinate of the original function, like negative 2 times f of x plus 5, or y equals negative 2 square root of x plus 5, where y equals square root of x was the original function. And we're going to look at transformations that take y equals f of x and move it to y equals a times f of bx minus c plus d, where a, b, c, and d are constants. We'll start with vertical shifts. Let's use transformations of the graph of y equals f of x to sketch y equals f of x plus 4. So if this is y equals f of x, this is just some random function, and I want to sketch y equals f of x plus 4. So I'm going to take all the f of x values, or y values, and add 4. So each of my y values gets moved up 4. The whole entire graph is moved up 4. So if I have a plus 4 at the end of the function, I move the graph up 4. And there is the computer-generated version of our new graph. Use transformations of the graph of y equals square root of x to sketch y equals square root of x minus 2. Here's the graph of y equals square root of x. If I subtract 2 from all the y values, the whole graph gets moved down 2. Notice it keeps the same shape as the original function, just was moved. Let's look at horizontal shifts. Let's use transformations of the graph of y equals square root of x to sketch y equals square root of x minus 3. This time the minus 3 is inside the square root, so we're changing the x coordinates. To see how this might transform on the graph, let's think about this point 0, 0. Here our y coordinate is 0. What would x have to be in the equation y equals square root of x minus 3 to get that same y coordinate? So if I were to substitute 3 for x, I would get the square root of 0, or 0. So x would have to be 3 to get that same y coordinate of 0. And same thing for the y coordinate of 1 and the y coordinate of 2. So our entire graph gets moved to the right 3. If the equation is y equals square root of x minus 3, we take the graph of square root of x and move it to the right 3. If we had something like y equals square root of x plus 2, the graph would be moved to the left 2. Vertical reflections. Use transformations of the graph y equals square root of x to sketch y equals negative square root of x. Here we want to change all of the y coordinates to their opposite, or the negative value. So this graph will get reflected across the x-axis. If we put a negative in front of an equation, we reflect the graph, we turn it upside down. A horizontal reflection would look like this, where we now start with the graph of y equals square root of x. We want to sketch y equals square root of negative x. So here's y equals square root of x. What would happen if I tried to substitute 1 in for x in my new equation? Then I'd have y equals the square root of negative 1, which is an imaginary number. Imaginary numbers don't show up on our real graph, so there's not going to be a point where x is 1. But if I substitute x equals negative 1, then I get y equals the square root of negative 1, which is the square root of 1, or 1. So that point that was 1, 1 now becomes negative 1, 1. And the point that was 4, 2 now becomes negative 4, 2. The entire graph gets reflected about the y-axis. Let's talk about vertical scalings next. So we're going to scale the graph by some factor. In this case, we're going to scale the graph of y equals the square root of x by a factor of 3 vertically. So all of our y values will be multiplied by 3. So here where the y value is 0, stays 0. where the y value was 1 is now 3. And where the y value was 2, 2 times 3 is now 6. 4, 5, 6. So my function was stretched, or my graph was stretched vertically. A horizontal scaling would be if I have the number, the scale factor inside of the square root. So I have y equals square root of x, and I want to sketch y equals 1/2 times x, square root of 1/2 times x. So let's see what would happen here. If I substitute in 1 into y equals square root of x, I have that 0.11. If I substitute 1 into the graph of square root of 1/2 times 1, I have the square root of 1/2, which is less than 1. So that point becomes some point right here. So what happens is we have what we call a horizontal stretch. Let's think about if we hold on to that arrow at the end in the green graph and we pull horizontally to the right, so we're stretching it horizontally, we'd end up with that red graph. It kind of gets moved, so it kind of looks like it's moved down, but it was stretched horizontally.